Okay, what we're going to talk about today is we're going to talk about AP Physics C, Mechanics, the 2020 exam that you're going to be taking online. And today we're going to concentrate on FRQ number 1, which they're calling question 1, and they're calling this the long free response. Why are they calling this the long free response? They're calling it the long free response because you're going to have 25 minutes to do this question, and you're all with an additional 5 minutes to upload, and this is going to be worth 60% of your exam. So that's why this is called the long free response. Now, these types of questions, the way they're going to be doing it is a lot of times you're going to be probably typing in your responses. I know you're used to working things mathematically, but I think they're trying to make it as easy as possible. So anyway, these types of questions, looking at what the College Board website says, the emphasis is on analyzing and explaining. So these are going to be concepts that you're going to see, and they said it's also could be represented by data, which means that maybe there'll be some graphs and you'll have to answer some questions on that. So the questions are going to have less emphasis on just pure calculations because of what's going on this year. Now, what you should be looking at is you should be looking at the handout that I gave you. So this one is called APC Mechanics Review 2020 exam, and what we're doing now is we're going over question number 1. So there's different types of things. They want you to analyze representation of physical situations, determine scientific questions and methods, develop an explanation or a scientific argument, analyze quantitative data represented in graphs. So there's a bunch of things that they want you to do. Now, what's interesting is that the explanation for this one has to do with the example they gave you is the 2017 AP Physics 1 as an example. So we're going to talk about this one. So in the folder on Google Classroom, I gave you a bunch of handouts. So of course, you want to take out the one I just showed you. Also is paragraph length responses. So this is for AP Physics 1 and 2, but you're going to be doing some of these things and answering your questions. And they're going to, a lot of times, probably ask you questions where they're going to say, if this happens, does it increase, decrease, or stay the same? And then they're going to say, justify your answer. And again, it says all here having to support the reasoning. So let's look at this first FRQ so we can see it's the types of things that we need to do. So first of all, when you're taking this test, you want to have all your handouts handy. You don't want to have a lot of stuff on your desk, but all of your basic handouts, you want to have everything handy and organized according maybe to topics, because you don't have time to dig through stuff. So the first thing you're going to do is look at the picture. I think they'll probably have a picture also for this first FRQ. So when you look at it right away, you see this disc is hitting this bar. So it says the left end of a rod of length D rotational inertia I is attached to a frictionless horizontal surface. So anyway, I'm not going to sit here and read the whole problem. I want to go over the skills that you're going to be using in order to solve the problem. So it says, suppose that, so it says the rod is initially motionless but is free to rotate, and they show you the pivot point. A student will slide a disc of mass M toward the rod with a velocity perpendicular rod. The disc will stick to the rod. So now you see that there's going to be a collision. The student wants the rod disc system to end up with as much angular speed as possible. So part A says, suppose the rod is much more massive than the disc. To give the rod as much angular speed as possible. So when you're reading these problems, you're going to say, okay, angular speed, omega. Should the student make the disc hit the rod to the left of point C, at C, or to the right? So this whole format where you're going to be given choices like A, B, and C, and then you have to explain your reasoning, this is the same format that your AP exam is going to do. It's going to be. So this is why they gave you this as an example. And you can see in part B, there's a yes or a no. Then you have to explain. You may be briefly on the bottom part have to maybe write like a couple of sentences. On the next part of it, they give you another scenario here. It says derive an equation. I don't know if they're going to do something like that. I think they're going to try and do that where you can just like type stuff in words. And then here, you're going to do the greater than, less than, or equal to, and then you have to explain this. So as far as the format of the test, that's probably what you're going to do. So if we go back to our handout, again, this was the one that they gave an example. My suggestion is to do types of questions, and I put this out. What I suggest you do is I suggest that you do other AP1 examples just so you're used to this format of writing. So when you look on the released AP Physics 1 FRQs that I put here, so we have the 2018. So again, for AP Physics 1 and 2, they call these QQTs. There was a QQT here in rotation, which you guys should be able to do. This is the example that they told you. Here's another one with kinematics and graphing, but this is again a QQT. The 2015. So these would be good examples for you to do as practice as far as the format is concerned. So the emphasis on this type of FRQ is that you're going to be explaining things, okay? So this is what we're going to talk about now. How do you do an explain question? Start off with this type of question, okay? Explain questions where I'm going to be explaining something. No matter what the problem is, the thing that I'm going to do is, you're going to look at it and it says, oh, explain something. So first of all, you want to look at the problem and you want to say, what's going on? If there's a collision, maybe I'm going to do something with conservation of momentum. If there's a change in height, maybe do something with conservation of energy. If, again, I want to identify is something rotating about an axis. So initially, I want to say, what are the physics principles involved? So that's always going to be the first step with this type of problem is, again, what are the physics principles involved? So the first thing, once I figure out what the physics principle is, then I might want to think about maybe some type of an equation. And the reason I think about an equation is I want to think about all the variables that are in that equation. If I was doing a problem with a pendulum, and there was a pendulum going back and forth, and they asked me something about the period, the first thing I say, well, the period of the pendulum, t is equal to 2 pi times the square root of L over J. Then they might, well, how would the period be affected if of the pendulum doubles? Or maybe they would ask me a question, what would happen to the period if mass doubles? Well, the mass isn't in the equation. It would remain the same. So sometimes when you look at it like this, if you write the equation down, it's going to help you to identify the variables that you're considering. So then when they ask you questions like, will a specific quantity increase, decrease, or remain the same, you can answer it. They might ask you by a certain factor. So again, after you check it, then you have to give evidence, but the going to have to do with that. The evidence has to do with what physics is going on in that particular question. So if you look at that handout they gave you, the handout's a couple of pages long, the same steps. So, explain how this varies with that. And then you're going to say, why is this? And there's certain things that you need to talk about. So when it says explain, think about, I'm going to be like solving for something. And then when you look at it in terms of the variables, that'll help you. So again, you always want to have the evidence, and you always want to mention whatever the physics concept is. You want to measure the variables and how that changes and things like that. So if there was a couple of questions, like if you look on page 3 of the handout, where we have a situation with different masses. And so if you look at page 3 of our handout, and they're going to ask you a question about the acceleration, you're going to end up, let's say, summing forces. Maybe you would do a free body diagram, some free body diagrams before that. You're going to sum forces, and you're going to be looking for the acceleration. Maybe you'll be looking for the tension. So you're going to see, once you see it mathematically and you rearrange the equation to say acceleration is equal to something, you'll say, well, whatever this is, if something here isn't affected, it's not going to affect that. Or if I have a mass here and I double this, well, then this would double everything else is the same. And that's why it's important to look at your equations, because your equations are going to help you to answer these, the questions that they're going to use. They're going to be asking you. So again, the physics is the physics. So I would recommend doing those FRQs and just to practice the format. Now another handout, there was a handout from another teacher. Besides that one, here's one that another teacher, her name's on the bottom, and she wrote AP Physics C 2020 Question 1 Preparation. So again, it talks about all this. So it talks about specific examples. And again, most of this, you're going to be typing this. So they could have a graph. So here she's showing, like, if you have a velocity versus time graph. Does the speed of the object increase, decrease, or stay the same? Justify your answer. So if you had a velocity versus time graph, the first thing you're going to say to yourself is, what do I know about a velocity versus time graph? I know in a velocity versus time graph, there's two things I know. I know the slope is the acceleration, and I know the area under the curve is the displacement. So if the question was, her example was, does the speed of the object increase, decrease, or stay the same? Justify your answer. Well, depending on the shape of the graph, I mean, this is a constant velocity, this is an increasing velocity, and then a changing velocity. So there's many scenarios you could have, but you would then say, well, on the graph, and you would say that what the slope represents. Because if I had a horizontal straight line, which would represent a zero slope, that would mean that it is a zero velocity, therefore the velocity is, a zero acceleration, so that would mean the velocity is constant. If I had a line like this, because the slope of the line represents the acceleration, I would see that even though it's a constant acceleration, that the slope anywhere on this line is the same, so it's a constant acceleration but a changing velocity. And a changing velocity, the definition of acceleration is the change in velocity with the change in time. So you have to think about, how am I going to explain this in words if they ask me a question? So there's all these different scenarios here about what possible types of questions they might ask you. Now, if you look at some of those AP Physics 1s, what was interesting is sometimes they had like one student did this and one student did that. And then you had to say which student was correct. So here, develop an explanation or a scientific argument. So they'll give you ones with two different students who have two different answers, and then you have to say which student is correct, why is it correct, and justify your answer. So again, on this test, what's out? They're not going to say calculate and derive, which we were doing all year. What they're going to do is, there's an equation, but you must say if the equation accurately models the physical situation, and things like this. You're going to predict how will a quantity change when one of the other ones is changed. So if I double this, what happens to that? Like the example with the period and the pendulum. Does the graph accurately describe the model? But again, look at here, the ins and the outs. So it's all going to be really a lot of questions as far as typing stuff, because even though they give you the option where you can write out your answers and you can take a picture and upload it, it's just another thing. And they even have a practice for you to do, and that's one of the things that you're going to have to do one day. So I gave you a bunch of handouts on Google Classroom just on FRQ number 1. So you should print all these handouts for FRQ number 1, which is really the QQT with explanations. And then we're going to be practicing these, and all the ones that I'm not giving for homework you should still do, so you can look at the rubrics and compare, am I getting a point for this, am I not getting a point